Okay, so let's start now. So you all can see the share screen, right?
Yeah.
Okay, come, let's start. Okay, so in the previous lessons, we actually covered all the way until the end of alkane already. So now we're going to go into alkenes. Okay, we're going to go into alkenes now. So let's start on this. Ishan, I'm going to mute you. Okay. Okay, so let's start now. Now, so for alkenes, it will be a similar format in terms of how we go about doing it. So for this worksheet, we'll focus on why is it considered unsaturated, what is the definition. Then after that, we'll look at the general formula of alkenes, followed by learning how to draw them out. So it will be for this worksheet. The next worksheet, it will be on physical properties and also the chemical properties as well. And I can tell you the chemical properties for alkenes is a lot more. So that one will be another lesson on its own as well. Okay, so let's start. So ethene is a hydrocarbon, has a formula of C2H4. So because of the E at the back here, you know it's an alkene. ETH. Okay, Arya, come first thing. ETH. How many carbon does ETH have? F represent how many carbon?
One.
One wrong. Increase one more.
Two.
Two carbon. So ETH represents two carbon, which actually the formula here actually shows already. So you can see it's a C2, so it contains two carbon. Okay. They mentioned it's a colorless flammable gas with a faint sweet and musky smell. Okay, this is the simplest alkene. I want you to take note of this idea that this is the simplest alkene. There will never, I say here, there is no one carbon alkene. Okay, there's no one carbon alkene. Joachim, can you tell me why is there never a one carbon alkene?
I don't know.
Okay, think about it. What's the functional group of alkene?
Double bond C.
Okay,
Carbon,
Okay.
carbon, double bond.
carbon double bond, right? So you realize in order for this to happen, carbon double bond, how many carbons must you have minimally?
Two.
So that's the reason why we cannot have a one carbon alkene, because minimally you need is two carbon. So the simplest alkene is actually a C2H4. There's no single carbon alkene, so just take note of that. Okay, come. Let's go on to the question itself. So let's define what alkenes are. So alkenes are hydrocarbons. So anyone can recall what exactly hydrocarbons are? Actually, don't want anyone. Next person will be Matthew. What are hydrocarbons? What's the definition of hydrocarbons?
Hydrocarbon, like the shit that only got like hydrogen and carbon inside.
Okay, that's one part of it, correct. There's another thing. What kind of compound are they called?
Organic.
Organic, correct. Okay, so they are actually organic compounds. So hydrocarbons actually represents their organic compounds with hydrogen and carbon only. Okay, so alkenes are hydrocarbons that contain carbon double bond. So you can see here in the definition itself, it actually talks about the functional group. Okay, because the functional group is the one that makes the homologous series. It helps to define the homologous series. Okay. Now, so this is the definition for alkene. Then the next question is, why are they considered unsaturated? Why are they considered unsaturated? So this is the reason why they are unsaturated.
Because they're not saturated.
Yeah, obviously they're not saturated. But why are they considered not saturated? It's because they contain what? They're unsaturated as they contain. What do you think it is? Anyone want to make a guess? So saturated, when we
They
talk about alkene,
contain nothing saturated.
okay, when we look at alkane, right, saturated means it contains carbon-carbon single bonds only. Carbon-carbon single bond only. Now, if I say alkene is unsaturated, means that they must contain, what do you think it is? Rehan.
Double bond. Carbon
Double-
double bond.
Okay, they must contain carbon-carbon double bond, or we will call it double covalent bond. Between the carbon atoms. Okay? Now, so what is so special about this double covalent bond between the carbon atoms? Because of the existence of this carbon-carbon double bond, okay, more atoms can be added across the carbon-carbon double bond. That's why it's unsaturated. Okay, it's not unsaturated means not saturated, means I can add more stuff. Okay, that's what the idea of saturation means. Okay, so more atoms can be added across the carbon-carbon double bond. Okay, so right now I'm going to share with you the general formula for alkene, general molecular formula for alkene. But before we go into that, Ryan, tell me what's the general molecular formula for alkane?
Alkane is
See what? I help you. CN. CN what?
CN food. It's like
What's the general molecular formula alkane?
CN then H 2N plus 2.
2n plus 2. Okay, good. So this is the general molecular formula for alkane. For alkene, it is just CnH2n. So there isn't the plus 2 there. Okay, there isn't the plus 2 there. So compare the difference. This is alkene versus the alkane, which has a plus 2. Be familiar with the general formula for alkane and alkene. So with that, next person, can I have Yixuan, you help me? Yixuan, can you help me for alkene? What's the formula for alkene if it has 2 carbon? So I want you to apply the general formula and tell me what's the formula for this.
C2H4.
C2H4. Okay? I think it's not too tough. Next one, Arya, you help me. C4. This one how?
C4H8.
Okay. Oh, Rehan, what you apply? I wanted Arya.
Oh, I thought you called me.
Never mind, now Arya turn. Arya.
Like C8, sorry, C8H16.
Correct. Okay, so this one will be your homework. You're going to try this one. So it's about getting used to applying the general formula. Okay? Can? Okay, let's move on. Now, let's go on to look at this particular one where we're going to fill up the first, actually not first 4, sorry, this is the first 3 members, okay, of alkenes. So for the first 3 members of alkenes, okay, we're going to do it here, which is 2 carbon, 3 carbon, 4 carbon. Now, Austin, if it is 2 carbon, what is the prefix? What's the starting part of the name if it's 2 carbon?
ETH. I think.
ETH.
I mean,
Then 3 leh?
sorry.
3 carbon now?
Rock.
4 carbon?
Built.
Okay. Now, thank you very much. Kiran, too bad he can't talk. Joachim, your turn. So if it's an alkene, what must the name end with?
ENE.
ENE. So what's going to happen? This will be ETH, ENE. This will be PROP, prop, ENE. This will be BUT, ENE. Can? Okay, Matthew, tell me all the molecular formula. All 3 of them.
C2H4,
C2H4,
C3H6,
C3H6,
and C4H8.
C4H8. Okay, so you all need to be very familiar with the molecular formula because it will always be tested, and it will come out quite often. Okay, so let's go about drawing. So whenever you see structural formula, it means I need to draw . Okay, draw the structural formula out. So for ethene, okay, so remember the way to draw is first thing, draw the carbon chain. Second thing, think in terms of the function, inserting the functional group. Then the last part is about filling up with H. So this is the order that we're going to do, and I'm going to show it to you again. That's a recap. So ethene, I got 2 carbon. Functional group, because it's alkene, I'm going to put a double bond. So you see the order that I'm drawing it. After that, I will check each carbon must have 4 bonds. So the focus is 4 bonds for carbon. So what it means that now the left side carbon, I got 2 bonds. I must draw 2 more H so that the carbon on the left will have 4 bonds. Right side already got 2 bonds. I'm going to draw another 2 more H around it, okay, to make sure that it has 4 bonds. So this is for ethene. Next one I'm going to draw for propene. So propene, I'm going to put here 3 carbons. Okay, Rehan, help me. Where should I put my double bond? The first one or second one?
First one.
First one. Actually, I tell you, it doesn't make a difference because this and this is the same because you can rotate the molecule. Make sense? If I turn the molecule 180 degrees, you realize they are both the same thing. Okay, so for propene, the rotation, actually, it doesn't matter. Both of these are actually the same propene they are drawing. Can, Rehan? Okay?
Yeah.
Okay, good. Now, so I'm going to cancel this part here. I'm just going to focus on this. So I've drawn the number of carbons. I've drawn the functional group. Last thing, I'm going to draw the H. So this carbon on the left side already have 2 bonds. So I'm going to draw 2 more H over here. Now, take note. People always overdraw the number of hydrogens on the carbon, especially when it's alkene. Because why? Typically, you will tend to, please don't chat privately, please don't chat privately, focus. Okay, people tend to overdraw the number of hydrogens, and hence the carbon tend to become like macam have 5 bonds, which is wrong. It will only have 4 bonds. So if I look at the middle carbon here, take note, left-hand side for this carbon, I already have 2 on the left, 1 on the right. So I'm only supposed to draw 1 more hydrogen over here. Okay, so be careful of this. And last one, hydrogen across here. Okay, butene, there's actually but1 in. Let me write it properly. So for butene, there's 2 possible drawings you can draw. You can either draw a but1 in, or you can draw a but2 in. Okay, but1 in or but2 in. So next one, Ryan, you help me. I'm going to draw the number of carbons first. Okay, Ryan, can you please tell me for but1 in, where should I put the double bond?
Is it the first one?
The first, between the first carbon and the second carbon, is it?
Yeah.
Okay, so between the first and second carbon. Then how about but2 in?
The next
Between
one.
the second and
The
third
middle one.
carbon.
Okay, between the second and third, the middle bond there. So this is but1 in, that's but2 in. Okay, so take note of this. After that, I'm just going to complete it with H.
Wait, but Mr. Eugene, isn't but1 in and but3 in the same because you can rotate it?
Yes, correct. That's why you realize I only got but1 and but2. There's no but3 in. Because but3 in is exactly the same as a but1 in. Okay? Okay? Then but2 in, just fill it up with the H. Okay? So this is the but1 in and but2 in. So get used to the drawing. You are going to be tested on a drawing quite a fair bit. Or at least you are supposed to be very familiar with the drawing. Yes.
Would it test anything outside like the 2, 3, 4 carbons? Like, can it test anything outside?
Typically, okay, you're expected to know up to 4.
Oh,
Okay, but if let's say I ask you for 5 carbon, let's say I tell you pent represents 5 carbon. I'll tell you in the question, pen represents 5 carbon. Then I ask you to draw a 5 carbon alkene. Then you just follow the rule that I have here. Just follow this rule, you won't go wrong. Can?
oh, okay.
The difficult part will come with the isomers. Where they ask you to draw the different isomers, then there's a lot more permutation. The larger the number of carbons, the more permutations you have for isomers. Can? Okay, so this is where we're going to go on to the next part now, isomerism. The remaining part of this lesson, I think we already looked into the isomerism quite a fair bit. So for alkanes, we focused a lot on chain isomerism. We focus on the branching out. That's why we did isomerism for alkane first. That's why I say, isomerism, I thought we learned, why must alkene come back again? Because there's two more types of isomerism that I'm going to teach you. One is called the positional isomerism. The other one is the functional group isomerism. Okay, positional isomerism. The other one is functional isomerism. So if I look at butte 1 in and butte 2 in, it is not a chain isomerism because there's no branching out of the carbon chain. Which one do you think this one is? Ishan, you help me. Do you think it's positional or functional isomerism?
Which one?
If I look at butte 1 in and butte 2 in, do you think is it a positional isomerism or do you think it's a functional group isomerism?
Is it functional?
You read the thing here, what does it say?
Oh, positional.
Positional. So because for functional group isomerism, you are changing the functional group, meaning if this is a C double bond C, if I do a functional group isomerism, I should not see my C double bond C anymore. It should become something else. That's what they mean by changing the functional group. Okay? Positional isomerism is about changing the important groups. So usually this one, we're looking at moving the functional group around. Make sense? Are we okay? Ken, for this one?
Yes.
Okay, good. Okay, so let's look at pentene now. Okay, pentene. So this is C5H10. The longest chain is 5 carbon. So I'm going to draw 5 carbon chain here. Another one, 5 carbon chain. Okay, Arya, you help me out. Why do you think there are 2 isomers for pentene? What do you think are the 2 isomers for this 5 carbon chain?
I don't know.
Anyone want to help him? How can the 5 carbon chain have isomerism? Think of chain, positional, and functional group isomerism. Anyone want to make a guess? Nobody? Okay, no one to guess. Then Arya, I'll call you back again. Okay, Arya, help me.
Yeah.
Is there any branching in this 5 carbon chain?
No.
Don't have. So that's why I'm not going to look at chain isomerism.
Yeah.
Okay. Now, in terms of I write it in this order because typically chain isomerism and positional isomerism are like in order kind of thing. So normally I'll explore the chain isomerism first, then I'll explore the positional isomerism. So in this case here, I tell you now it's going to be a positional isomerism. That means it's about the functional group being placed on different parts of the chain. If this is a pentene, what is the functional group?
Is this a what?
If this is pentene, what is the functional group?
Like
ENE.
Oh.
What is the
Alkene.
homologous series?
alkene.
Alkene. So what's the functional group for alkene?
Wait. Functional group for alkene is carbon-carbon double bond.
Carbon-carbon double bond. Okay. So I want to move the carbon-carbon double bond. So think about it. For the first carbon chain, where would you put the double bond?
Right at the start.
At the start. So I'll put here, right?
Yeah.
I don't know why there's a blue line. Sorry. Let me erase this part first. Okay, so I put double bond here. Now, now let's look at the chain at the bottom. Where would you put, if I want a different molecule, I want an isomer, where would you put the double bond?
In the middle.
There's no middle. Where's the middle?
Or like the second one.
Second one. Okay, second one. Austin, I'll call you back again. Austin.
Yeah.
For the first one, what do you think is the name of this guy here? I haven't drawn the H yet. This is called pen what?
Pen 1
Pen 1?
in,
In. Okay, then this guy here?
pen 2 in.
Pen 2 in. Now, my question to you is, why is there no pen 3 in and pen 4 in?
Because pen 3 in is just 2 but reversed, and pen 4 in is just 1 but reversed.
Correct. So I just need you to take note. That's why there's only 2 isomerism for the longest chain, because pen 4 in is actually the same as a pen 1 in. All okay? Thumbs up if you're okay. Practice your thumbs up. Let's go.
Yes, Mr. Eugene.
Okay. So this is the thing here. Then let's finish up with the number of H. Okay. Let's finish out with the H. Now this question also is quite clear. They actually tell you, they just want you to explore chain isomerism and functional group isomerism. So you realize that the longest chain for 4 carbons, there's 3 different isomers here. So actually the tree tells you that there's 3 different isomers for 4 carbon chain. Okay, so let's do this. I'm going to draw 4 carbon chain here. 1 4 carbon chain, 2 4 carbon chain, and then 3 4 carbon chain. Okay? Now, just not got Austin here. Joachim, help me.
Yeah.
I want to do a single carbon branching out. Where can I branch it out from?
The second or the third carbon.
Second or third carbon. Actually, then my question to you is branching out from the second and branching out from the third carbon the same thing?
Yes.
It is, right? Cause can rotate. So let's branch it out from the second carbon. All right, let's all branch it out from the second carbon. So this is my all branching out from my second carbon. Okay. Next one will be Matthew.
Yeah.
I've covered all the carbons already. So all got 5 carbons already. The branching all done. The next one I'm going to do is the position of the functional group. Where can I place my double bond?
You can place it at the first carbon-carbon bond.
First one. Then the second one, I can place where?
You can place it at the the vertical one.
Okay, I tell you what, by doing this, these two are actually the same thing. So if I were to look at what you have suggested, actually these two are actually the same. Because these two this one and this one can swap positions. Make sense? You can actually rotate the molecule. Rotate the bonds around that particular carbon. So this one cannot. Okay? Cannot. So let's erase this. I'll tell you cannot put at the vertical one. Then where are you going to put next?
The second horizontal one.
Second horizontal one. Then the last one?
The third horizontal.
Third horizontal one. Then this is where I'm going to go back to Austin again. Austin. Why I cannot rotate and then say it's the same thing?
Like for the second one.
For the first one and the third one, why I cannot say I just rotate? Actually, aren't they the same thing? The other one's on the first 2 carbon. Then after that, the double one is the last 2 carbon.
Because if you flip it, right, the carbon single bond will be at a different position.
So because of the branching, you realize that it is not symmetrical. It's not the same thing. Make sense? So what you are saying is correct. So this is the part where people always think that rotate, always the same thing. No, you must look at the molecule as a whole. Okay, don't just always imagine that the first thing and the last one always cannot. Whenever there's branching, you must now look at the whole molecule as a whole. When you flip it, it's now actually different stuff. So just take note of it. Okay, once I've drawn this tree, then it's just filling up with hydrogens. Okay, filling up hydrogens.
Wait, Mr. Eugene,
Yes.
why is the vertical carbon at the second one?
Because you cannot put it on the first or the last one. By putting it on the first or the last one, actually it becomes a 5 carbon chain. Because it's continuous, you can do it as a continuous chain. So far, okay?
Oh, so it can be the third one also.
Yeah, it can be a third one, but the problem if you put it on the third one, it's the same as putting it on the second one. Make sense?
Yeah.
Okay, so this is the intricacies of organic chemistry that really you will need to visualize it in terms of the 3D space. I can honestly tell you if your 3D spacing, if your 3D visualization is not so strong, if you do organic chem in uni, right, you might face some struggles. because the 3D visualization actually is quite critical, okay, for the organic chem, okay, in tertiary education. Okay, Ken? So just take note of that thing lah. Okay, next.
Hey Eugene, what
Yes.
is tertiary education?
Like JC and university lah.
Oh,
Okay, there'll
Thank
be a
you.
little bit more visualization when it comes to your tertiary education. Hey, do you need me to write down all the H for this one? Can I be lazy and don't write the H? Cannot.
yes, Mr. Eugene.
Can be lazy. Okay, so I'll leave John to you all to go and fill up. Okay, now, part 2. This one now will focus on functional group isomerism. So I need to change the functional group. So if it is pentene, I can no longer put double bond. So now it's a C5H10, but no C double bond C. So it's no longer called pentene already. It's a C5H10, but no C double bond C. What would be a possible functional group? This one is where it gets exciting. Okay, I show you how it looks. So in order to not have a C double bond C, but yet still have this C5H10, this is the first isomer. So you can see this is this is cyclical, right? Can you see it's like a pentagon shape? Make sense? This is called a cyclopentane because it's in a cyclical shape. It is an alkane because there's no C double bond C. Okay, and it contains 5 carbon. So this is called cyclopentane. You don't need to know the names. Ken?
Wait, why is it in a circle? Why can't it just be one line?
If it's one line, then you cannot get C5H10. You'll be short of You'll be short of hydrogens. So you want to make sure that for isomers, just recap, you want to have the same molecular formula, but then you want to have a different structure. That's the idea of your isomer. So you want same molecular formula, that means the same number of carbons, same number of hydrogens, but you want the structure to look different. That's what your isomers are. So if I don't have it in a cycle, if you have it in a straight chain, you realize that you can never ever have a C5H10 without a C double bond C. Okay? You all can go and try lah. You can go and try. As long as you don't cycle it, it won't happen. Okay? And if okay, thumbs up so I know I can carry on.
Okay.
You don't okay lah, you thumbs up can you practice the emoticon?
How you do it?
Oh my gosh. No wonder you haven't been doing it because you don't know how to do it, right?
Yeah.
Can you see there's a smiley face there? Then you press the smiley face.
Smiley face. Oh, this one.
I cannot see what you're pressing, but yeah. You see Austin keep doing the thing. Okay, can. Okay,
Okay, spam one. Okay, I understand.
Hey, hello, don't keep spamming us, smack you.
How come I cannot see mine? I can only see Austin's end. Oh, I see mine now.
Okay, next. Okay, so let's go to isomer 2. Isomer 2, I'm going to draw for you also because I don't think you're... Okay, just anyone to make a guess, okay, before I say the answer. Anyone make a guess, how can I do functional group isomerism with C5H10? What do you think is another functional group isomer that I can do with C5H10? Anyone to make a guess? Asan?
Right. C5H10.
Yeah, C5H10. I want to have another isomer. C5H10. How do you think the structure will look? I give you a clue. It must be cyclo.
It's all like single bond, right?
Yeah, it's all single bond. But there must be cyclo. Otherwise, you cannot have C5H10. What's the next possible cyclo you can draw?
Wait, can you draw like a circle of carbons and then it's just a line of hydrogens connected to it?
Cannot. Because if you draw a circle of carbon, it's still 5 carbon joined together.
Yeah, but then there's still the hydrogens, the line of hydrogens. So isn't there still C5H10?
Okay, so you're still saying like that, right?
Yeah.
As long as you got like that, it is still cyclopentane.
Oh, okay.
Yeah, so good try. Okay, so this one, whether a circle or pentagon, actually the key idea here is as long as 5 carbon linked up together in a circle, it is still considered a cyclopentane. Okay, how? Give you another try, come. Asan, anyone want to help Asan? Oh, Asan, you want to say something? Come, say.
no, like, I have no idea.
Then next one, Joachim, come.
I still don't know. You make it like a rectangle or something.
Rectangle consists of how many sides? How many corners?
Why can't you just add one in the middle? Like the middle of the one line.
The middle and one line.
Yeah, like you just make your bottom line really long.
The line is the bond. The bond long or short doesn't make a difference.
Wait, Mr. Eugene.
Yes.
Can you just connect 4 and then you add 1 extra carbon outside?
Like that.
Yeah, something
Then
like
one
that.
extra
Then one
carbon,
more
right?
carbon. Yeah.
So this is correct lah. This is actually your methyl cyclo butane. So actually this is how it looks. So what Eugene said is correct. So you can see I still have one cyclo side to it. Then I have one branching out methyl group. So this is another one. So actually the question I have now is, do you think there's a third possible isomer that I can draw with this one?
A triangle.
Triangle lah. So you can actually think of it as a triangle like that. Okay, then after that, there's only 3 carbon, right?
2 carbons branching out of the other 2.
Can see this? This one is possible in terms of drawing, but in real life, generally you won't see this because it is quite unstable. Okay, but in actual fact, this is another possible isomer. Any
What's it called?
questions? This is called a 1,2 dimethyl propane. It's cyclopropane.
Why is it propane? Like it went from pentane to butane to propane.
Because the cycle here, ma. Can you see 3 carbon in
Oh,
the cycle?
Yeah,
Then I got
and then
one
it's
methyl
in-
group branching out, one methyl group branching out.
Oh yeah.
Any other question? Any other people got question for this? Okay, now then I got question for you. Rehan, must you remember all the names I mentioned?
No.
I
No,
don't think so.
don't need. So you don't need to remember all the names, huh? Do you need to know how to name like what I name? Do you need to know?
Don't need.
Don't need, huh? So all you need to do is just be creative and think, and so-called like have this divergent thinking on what are the possibilities, okay, in terms of the isomers. Can? So don't be so hard up on the naming. Don't be so hard up on all the naming. The focus is, can you think of other patterns in terms of isomers? Are you able to show me that you have the same molecular formula but different structure? So this is the key thing I want you to take note whenever you're doing isomerism. It is not about the name, but about trying to find different structures with the same molecular formula. Okay? Thumbs up if all okay. Okay, so whenever you start doing isomers, this one I would spend a little bit more time on it. It's just to show you the different things. But please don't go and spend all your time trying to memorize all isomers. There's no need, okay, just be on the spot. Just try to figure out what are the various things that you all can explore doing to have different structures for the molecule. Okay, now this is another possibility one. So part B, you all go and do as homework. So you all can go and try it out. Then you can send me a picture of it and I can check for you. Okay, so this is to get you to be familiar with what exactly chain isomerism is, what exactly positional isomerism is, and what is the functional group isomerism is. Okay, why I want to introduce to you this term, you realize in your textbook never talk about it. How come you tell me about it here? It's so that you're able to have different permutations based on the type of isomerism. When I say again, it's just to introduce you the type of isomerism so you can be able to create the different permutations. Okay, so that's for this part here. Now, let's go on to the last part, which is question 4. Yay. So question 4, this one should be easy one. Austin, yay. Give me the first characteristic. You're the first one, so you can say anything.
Well, I mean, like any homologous series.
No lah, state 5 characteristics of homologous series. So what? Give me any one of this.
What?
What?
Yeah, what?
What? Okay, then you pause here first. Joakim, can you give me one?
Like, can I do the first one?
Yeah, can anything. Just give me any one.
Same functional group.
Okay, so all the members in the same homologous series will have the same functional group. Okay, they will have the same functional group. Austin, go back to you again. Give me another one. We covered just now. What is this? What is this thing called?
What? Same formula.
What formula? There's a specific name to this formula.
Same general molecular formula.
Okay, so they have the same general molecular formula. Okay, so now you're sped already.
Isn't it just general formula?
Yep. So general formula also can, but I tend to you can put the word molecular there so that you're really looking at the molecule itself. Next one will be Matthew. Give me another one.
There's a gradual change in their chemical properties as they go down as one goes down the series.
Chemical properties here. You sure?
How's it physical?
This physical, this not chemical, this physical. So physical properties is the one that will change gradually. So as I mentioned, this one is your melting point or boiling point. Or we normally can also talk about viscosity here. Can? Okay, next one, Rehan, give me another one. You left 2 more.
Oh, they have similar chemical properties.
Okay, similar chemical properties, good. What does chemical properties mean?
MR.
MR, no. Start with R. If I say they have similar, I wouldn't say reactivity, but it's close. They have the same what?
Like the reaction.
Yep, they undergo the same reaction. So just like alkane, all the alkane will undergo substitution reaction. All of the alkane will undergo combustion. So when you talk about similar chemical properties, I want to drive back the point. They will all have the same reaction. They undergo the same type of reactions. Can? Okay. Last one. Ishan, you last one. Come.
Okay.
I help you. I draw a first dash there. This is a formula.
By -2.
What?
I don't know.
Is it carbon-carbon bond?
No, not carbon-carbon bond. I show you. C2H4, C3H6, C4H8. From one to the next. What's the difference?
CH2.
Yep. So this is a They differ from the next by a CH2 unit. So these 5 homologous series, you realize I will keep re-emphasizing it after every single introduction of a homologous series, because it is exactly the same thing, you must remember. Right? In terms of they have the same functional group, same reactions. So it doesn't matter whether it's alkane, it doesn't matter whether it's a methane, propane, butane, or decacane. As long as all of them are alkane, they all undergo the same type of reaction. So all those in the same homologous series, they will always exhibit these characteristics. Ken? All okay? Any questions?
No.
No? Okay, I'm going to push on to the next worksheet. Just only the very front part where we look at the physical properties. Okay, then I'll just end here already. Okay, so I'm just going to fill up all these blanks. So we know previously in the previous part, it is that the physical properties will show some gradual change when you go down the homologous series. Homologous series. Okay? So we explained this at the start of alkane, at the physical property of alkane. The reasoning is exactly the same as well. So first thing, let's recap. Alkenes like alkanes, what are they? They are covalent compounds. Recap. So next one will be back to Arya. Arya, can you help me? Covalent compounds means what?
Covalent compounds.
Yeah, if they are covalent compounds, what are the type of elements involved here?
Like different elements.
Different or compounds, yes. Compound means different element, correct. But carbon and hydrogens, both of them are classified as what
Is
kind
it
of
non-metals?
non-metals, correct? So
Metal.
non-metals are. So why are alkenes and alkanes covalent compounds? Because they're made out of non-metals, which is carbon and hydrogen. Okay? They have simple molecular structure, okay, which we covered already. And hence all the properties here exhibited are actually that of a simple covalent molecular structure. So recapping on your bonding again, okay, so you realize that this part here is to recap on your bonding. So we're going to go back to bonding and recap all this again. Next one, Asan. Okay, make a guess. Going down the homologous series, the viscosity, the melting and boiling point, increase or decrease?
Increase.
Increase. Good. Next one, Austin. Going down the homologous series, the viscosity increase or decrease?
Going down.
Yeah, going down. That means from methane to ethane. From ethene to propene to butene. From one
The
to the next.
viscosity increases.
Increases. Good. Okay. Next one. Joachim. Going down the homologous series, the alkene molecule size, what happens to it?
Increases.
Increases. How do you know it increases? Because you can see here C2H4. This one becomes C3H6. This one becomes C4H8. So you know that the molecule is getting bigger. This means that the MR will become higher. Matthew, next one.
Wait, Mr. Eugene,
Yes.
when they say viscosity increases, right? Like, that's like what's that specifically?
It means that it becomes thicker. Just think of lava. The higher the viscosity, the harder it is to flow. Think of it like a very thick, gooey liquid. So slime has very high viscosity. Make sense?
Yeah.
Okay. Syrup has very high viscosity. Water has very low viscosity because it can just flow very easily. Okay? Okay, Matthew. Yes. So when there's higher MR, what happens to the intermolecular force of attraction?
They increase.
Increases. So if the intermolecular force of attraction increases, next one will be red. Okay, then since you help Rehan, more energy is required to overcome these forces of attraction. Hence, melting boiling point increase. Hence, viscosity increase. Ken? Any questions for this one? All okay? Thumbs up if all okay. Thumbs up, faster, thumbs up, thumbs up. Yeah, today don't have Akit, but never mind. Arya help me replace Akit. Because Akit always give me the heart. but it's okay. Ken.
Thank you.
Hey. Okay, Ken, don't give me so many hearts. Later I scared, huh? Too much hearts. Later my heart cannot take it. Huh? Okay, next one. Now, alkenes, just like alkanes. So now we are going on to the chemical properties already, which is the reaction. I will stop after this combustion part. This one is about reaction. I'm going to stop here. Okay. So alkenes also undergo combustion when reacted with oxygen. Okay, so I want to do balancing for butene. Balancing for butene. So I'm going to have C4H8. When I undergo combustion, to be more precise, complete combustion. Next one will be Rehan. Rehan, you help me. If undergo complete combustion, what does a butene react with?
Oxygen, O2.
O2. What's the product?
H2O,
H2O, okay. And
carbon.
carbon. Confirm,
Yeah.
Ryan, please help him. What do you think is the thing?
Oh wait, do I balance it?
No, haven't balanced it. What's the product, Ryan?
Yeah, carbon dioxide.
Carbon dioxide, So actually think of it as your carbon gaining oxygen and hydrogen gaining oxygen after it undergoes combustion. Ken, Rehan, okay?
Yeah.
Okay, so now once you have the equation out, then we start to balance. Okay? Ryan, you help me. What should I put in front of the carbon dioxide?
In front of the carbon dioxide.
Oh, sorry, we change first. How to balance combustion? What should be the order of the element which I should balance?
Is it the H2O?
What's the first element I should balance? Which element should I balance first?
Or hydrogen?
Nope, not hydrogen first. Sorry, hydrogen is number 2.
Oh, then surely it's carbon.
So first one I balance, I should be carbon, then hydrogen, then last one is?
Oxygen.
Okay, but actually these two no difference. Whatever you balance first is the same thing. But okay, let's say I balance carbon first. Okay. How to balance carbon? What would you do, Ryan?
I'll put 4.
4 in front of carbon dioxide. Okay, next Yishuan, help me. What would I put in front of the water? Yishuan.
Put
2. Confirm 2. Confirm. I want to balance hydrogen.
yeah.
If I put
No,
2 here, can
Wait, no. 4.
Then what's 4? Okay, so I'm going to put a 4 here so that I also have 8 hydrogens. Now, last one, Arya, help me. What should I put in front of the oxygen here? I want to balance oxygen.
Wait. 4.
4, confirm no?
Wait. You one sec.
So stressed.
6.
6. Okay, good. It's 6. Can? So, heptane, go back and do as homework. Okay, so this will be your homework for you to practice your combustion reaction again. Can? Okay, so for today, I'm going to stop here. Question 3 onwards, I'll do the next week. Okay, so that's all from me. I'm going to stop the recording now.